So we're just going to quickly go over the remaining ones and the strategy you should use to solve them. So for this one, they're asking you to graph it, but what you need to do when they give you formulas like this that don't really make sense is that they're asking you to put it into a standard form. So you need to look at the standard forms you've been given that you've learned in these sections to see which one it might fit into. So for instance, this is the standard form you were given for parabola. And so this looks like you've got a y squared. So this might work here. So you should put this into the format for a parabola. Same deal with this one, where they're giving you a big long formula and they want you to put it into a standard form. So you can guess by what they're asking for the focus and the vertices, that they want you to look at the standard form for an ellipse and try to put that into the form for an ellipse. In this one, they're actually telling you in its ellipse with a focus and vertices. So you're just going to look at the standard forms, you're going to figure out what you have and what you don't have, and then just graph it exactly how it says to graph an ellipse. And with number 10, once again, it gave you what it is, thankfully, so you can use the standard form for hyperbola, and then it gave you the vertices, asymptote, and even the equation. So you just look at what you have, solve for what you don't have, and then go ahead and graph it. For number 11, this is another where you're given a hint based on you being asked for vertices, asymptote, and an equation, that you're going to be putting this into the standard format for a hyperbola. And then number 12 is a word problem. So it gives you the distance between two stations, the amount of time that a signal is received, and then a speed of how fast it's received. And so you're given units, miles, seconds, and miles per second. So you've got some conversion that can be done here. Now, this, if you were to say that the distance from the boat to the stations is D1 or D2, you can say D1 plus D2 equals to this big D of 100 miles. And then you should be able to get a certain amount of miles here by multiplying these two together, because if you're doing miles per second times second, you'll just get you'll get miles. So that should give you another distance. And then when you've got D1 minus D2, you should get that distance. We'll call it a distance x. So now you don't know D1 or D2, but since you do know big D, it's 100 miles, and you can find dx, it would be by multiplying these together, then you can combine these equations to be able to solve D1 or D2 or both of them by, moving over. You can move over D2, move over D2, and then you have D1 equals and D1 equals. Then you can set those two equations equal to each other.